In this video tutorial, I am explaining the rules of naming ethers. The functional group, the general formula of ethers is CnH2n plus 1 OH, and they have a functional group R bonded to O and then bonded to R, or they could be different alkyl groups. So it's O in the middle, the ether group, it's an O bonded to two carbons on each side. Ether and alcohols, they have the same general formula, CnH2n plus 1 OH, and later on they are functional isomers. We will talk about isomers in a different video. So when I want to name ether, first of all I have to recognize the radicals or the alkyl groups attached to the oxygen. So as you can see over here, for example, this is the first alkyl group attached to the oxygen, and this is the second alkyl group attached to the oxygen. One side will take the name of alkoxy, and the other one will be named as an alkane. So for example, now these sides are both the same. So one will be etoxy, and then the other one will be ethane. Now, of course, there's another way, which is the easy way of naming ether. You name each side and followed by ether. So diethyl ether, this one. Now, looking at the second one over here, the oxygen functional group is over here. So this oxygen is attached to this first R, and this is the second R. The group that is going to be ended with the prefix or alkoxy is the one with less carbon to it. So this is going to be the methoxy, and the other one will be named following the rules of alkane. So 1, 2, 3, I have 2 bromo propane. I cannot name this following the easy way of naming ether because I have a substitution in the other alkyl group bonded to oxygen. Looking at this one over here, so this is the first R and this is the second R. So of course the one with the shorter carbon will take the oxy group. So this is methoxy, and then the second one will be, so in numbering the second one, of course we're gonna number the carbon closer to the functional group. So 1, 2, 3, and 4. So this is 2 methoxy because the alkoxy group is bonded to carbon number 2. 2 methoxy butane. In this one, we should, I forgot to mention, we should say 1 methoxy 2 bromopropane, knowing that this oxygen, we consider this as a whole, as a substitution. So it's attached to the first carbon. Looking at this example over here, this is the first group, the first R bonded to O, and this is the second R bonded to O. This will take the alkoxy termination. So numbering the other chain, this is how we're going to number it. If I start from here, 1, 2, 3, the alkoxy group will be attached to carbon number 3. But if I number from the other side, 1, 2, 3, 4, it will be attached to carbon number 4. So the priority is for the alkoxy group to be attached to the lowest number of numbered carbon. So here 3, 4, 5, and 6. So I have a 3. This is 2 carbon, so it will be ethoxy. Now I have a chloro group bonded to it. It is on carbon number 5, so I say 5 chloro, and the main chain is made up of 6 carbon. It's going to be hexane. Now, in ordering the name of this one, the chloro has letter C, which in the alphabetical order comes before the E. So the naming will be as follows: 5 chloro, 3 ethoxy, hexane. Let's look at other examples on the next slide. So as you can see here, I have 2 ether. This is the smallest chain, so this takes the oxy group. So in both of these are methoxy. I have a chain of 3 carbon, so this is methoxypropane, and this is attached. The whole group of ether is attached to this carbon, which is numbered 1. So it is 1 methoxypropane. Same thing here, 1 methoxybutane. Now let's write the formula of these ethers. So when you are reading the name of an ether, you should know the parts of the ether. So I'm looking at this one. I have 4 methoxy. So it means I have a CH3 bonded to O attached to the 4th carbon of the chain. The chain that is made up of 8 carbon. So this is 4, 3, 2, 1, and the chain continues: 5 carbon, 6 carbon, 7, and 8 carbon. Of course, we can draw this as a straight chain, but this way I did it, I find it much easier. So 4 methoxy, and I have an octane, and on the 2nd carbon I have Cl. So now let's write it in a very nice way. Here's a chain of 8 carbon: 1, 2, 3, 4, 5, 6, 7, 8. On the 2nd one we have a Cl group, and on the 4th one we have O bonded to CH3. This is 2-chloro-4-methoxy octane. Now naming the second given example of ether, the 5-methoxy-2-hexene. So I have here the number over here, the 5-methoxy. So I have a methyl group attached to O, and this methoxy group is attached to carbon number 5 in the main chain of the ether, because it's written 5-methoxy. So this is the carbon numbered 5. The whole main chain is hexene, which is made up of 6 carbons. So this is the 6th carbon. This is carbon number 6. This is carbon, the 4th one, the 3rd, the 2nd, and the 1st. Now note here that we have 2 ene. So it means on the 2nd carbon we had a double bond. And in the case of naming an alkene, an ether, and this ether contain a double bond, the priority here now goes for the double bond. So we should start numbering the carbon chain from the side closer to the double bond. This is why when we started numbering this one, we started from here: 1, 2, 3, 4, and 5. So the methoxy was on the 5th carbon. So if I want to write this one, I will write a chain of 6 carbon, 3, 4, 5, 6, a double bond on the 2nd carbon, and on the fifth carbon an O bonded to CH3. Of course, we have to fill the rest with hydrogens. Now, writing the formula of the third example, I have a 3,5-diethoxyheptane. When I read a di-ethoxy, it means I have two functional groups of ether. So this is O bonded to CH3 on connected to the carbon number 3. So this is the third carbon. Of course, before that third carbon, there was the second and the first carbon, and then fourth carbon, fifth carbon. On this fifth carbon, we had the other methoxy group, and the chain continues to 7 carbons. So 1, 2, 3, 4, 5, 6, and 7. So the best way to draw this, we first put a carbon of a chain of 7 carbon. So let's do it over here. 1, 2, 3, 4, 5, 6, 7. On the third carbon, I have a methoxy group, and on the fifth carbon, I have another methoxy. Sorry, it's an ethoxy group, so it should be CH2, CH3. Sorry, so here it's ethoxy, CH2, CH3, and heptane. So this is the final formula of 3,5-diethoxyheptane. Let's move to the next slide. The two given compounds are ether, but named the following the easy way. So the easy naming of ether is only used when there are no substituents or branches in the main chain. So it's each R group are named as alkyl groups followed by the word ether. So when I see methyl ether, this is methyl ether, and this is ethyl group. So methyl, ethyl. So when I name this, of course, the E is pronounced before the M. The second one is methyl propyl. So here's the ether function. On one side, it is bonded to a methyl group, and on the other side, it is bonded to a propyl chain of 3 carbons.